Hello all, welcome again to the discussion of ARM processor. This is third part discussion of ARM processor unit 3 under EIoT subject. So what we have just focused on versions of ARM, features of ARM and architecture representation of one of the version of ARM family, ARM7. So whenever we focus on or whenever we concentrate on learning of any one of the architectures of any selected microcontroller or processor, we would like to focus on some basic strategies like the procedure goes, learn through its features, then learn through its block diagram, then learn through its programming model. So with respect to ARM7 version, we have looked over the architecture model. In that we had a visibility of register bank. If we take a inside look of this register bank, now what we see on the screen is some set of 16 registers, then a CPSR and SPSR arrangement of register set. What are these things? What are the other names that we see on the screen have their own meaning to represent. So if we say our ARM7 processor works on certain operating modes, and these operating modes are considered as a normal mode. Whenever a microcontroller or processor of ARM category is working on very simple or very generalized mode, it is treated as user mode. And when it is working on some special modes, we consider them as privileged mode. To our goodness, we can easily remember like these are not some new names that we are learning, saying like if at all we select any other earlier microcontroller also, though it doesn't has a heading representation, they used to work on some special privileged operations. For example, any processor and any microcontroller design is incomplete if it doesn't has an interrupt architecture inside that. So when a controller or processor is leaving its current position and operating on some interrupt request, then it is treated as interrupt service routine mode. And if it is working specifically on masked interrupts, it is one state. If it is working specifically on non-maskable interrupts, it is another state. Such states are now cumulated with some headings and are being given as some privileged modes names under ARM architecture. So together we will be having 7 operating modes. The generalized names are being shown as user mode, FIQ stands for fast interrupt mode, saying like non-maskable area. IRQ is general interrupt request mode. Abort, not working or locked mode. Undefined supervisor mode. When it is working on its internal operations, it is treated as system mode. How they cooperate with each other and how the registers in each mode will be active, or how many registers will be active for each mode, we can have a simple look, stating with what's the meaning of each mode. Unprivileged mode, where a general task, general operation is carried out by the ARM ALU, is treated under user mode. Then specific modes have their own intention. For example, if I say supervisor mode, entered on reset when software interrupt instruction is operated. System mode, privileged mode using the same register as user mode but not giving any sort of IO operations. Undefined mode, whenever some exceptional instructions are to be handled, we consider it as undefined mode. They have a similar meaning like abort, but it is different. Whenever it is having some problem or whenever it is having some delay from the memory operations, we consider like stop or just avoid these modes or delay these operations. Whenever it is saying like delay or stop, we consider it as abort mode. These are all condition control operations. These are all operating functions, saying like they will work on some data. So if we continue saying like what happens internally, this is the representation. Now, one of the arrangements shown here is user mode. When it is user mode, what are all the registers that are active here? Are total 16 registers get active. The last 3 registers in the higher category have their own other multiplexed specialties, saying like program counter, location register, stack pointer. Stack pointer maps to the top of the stack. Location register holds the address of the current instruction. PC stands with the address of the next instruction to be executed. Well, it is known as program counter. The sizes of all these registers is standard 32-bit registers, and one more register, which in other words is treated as flag register or status word register or program status word or CPSR, current program status register. These are all treated as user mode general registers which are used. Suppose we shift from one mode to another mode, we can see like what are the registers that are getting highlighted here. So we will be having only R13, R14 and SPSR, saved program status register, operating in this. If we see FIQ mode, what happens in this? Along with SP, LR and SPCR, R8, R9, R10 and R11 to R12 are being utilized for the operations. So we can see the statement saying like a subset of 3 registers is accessible in each mode here. So then with respect to user mode or undefined mode, then we have user mode, IRQ mode, FIQ mode. Then we can go for supervisory mode, in which again SPSR and SPL are being utilized. Then we have user mode back. Then we'll go for undefined mode. Most of the things show like at most privileged modes, R13, R14 and saved program status register are being utilized. SPSR is another known strategy to us. It is not a new register that is specially designed here. Maybe we have heard this saving of address saving register. When an interrupt occurs in a processor operation or a subroutine is called in a processor operation, the current status and current operations are being saved. The status of the current operation is saved in some SAR arrangement. The same thing is happening here with respect to ARM. When it is shifting from user mode to any other privilege mode, it is preserving all its CPSR values in SPSR. Because whenever it comes back, we are seeing this. Whenever it comes back, it has come back to user mode, then shifted to other modes. So whenever it comes back, it will put back all the SPSR values in the CPSR, making the system restart, or I don't say restart, making the system to reinitiate its work from the place it has stopped for operation. Now we can see the same situation for user mode, abort mode and all. These are some representations with respect to the patterns of register organization. One of the most another prominent register we find is status register. 32 bits are being dedicated for CPSR register for ARM7 version, out of which most popularly utilized versions, utilized arrangements are being represented in the image here. Many known names are there saying like carry, zero, sign, nothing but negative or positive, overflow. Some of the other routine names: interrupt request, non-maskable request, FIQ, fast request, thumb mode. Thumb mode is a place where we can reduce the quantity of instructions that we are indicating here. If t is equal to 1 indicates thumb execution, saying like when instructions can be shown in shorter form, then we will prefer for thumb instruction arrangements. So remaining all are right now reserved situations for us. They will be utilized for some other versions or later operations. And this is the arrangement which is mostly used for processor applications in user mode and all, right? So detailed discussion of each operation with respect to other versions of ARM processor. Saying like we'll be having some extra bits Q. Then we'll be having some extra bits J. J here stands for Jezel condition. Then we'll be having some other extra bits here saying like X. X has its own representation based on its version. So these are some discussion we can provide on the register set of the ARM processor. There we end part 3. Then we'll have a last part of discussion to end up ARM processor operations. Thank you.